Hi, everyone. Yeah, so my name is Steve Reed. I reside in Orlando, Florida, and I've been working on mainframe transformation at Microsoft for about 6 years. I've been at Microsoft for 24 years and in various technical roles. And before that, I actually was a mainframe developer. So I was in the world of COBOL, vSAM, CICS, DB2, and all of that. And then I also was a Unix developer. My intent today is really just to sort of give you, what I can in 20 minutes, an overview of the paths of modernizing the mainframe and some of the challenges to be aware of, and just some of the things that need to be top of mind for you when you are thinking about doing this. So that's really my goal. Let me go ahead and get started because framing all of this, Ron and I were very sort of cognizant of, the intent of this is technical debt, right? And how do we retire that? My topics here, as far as what I'm going to address, is the concerns and what exactly do we mean by technical debt, and then also to get into, you know, at a deeper level, sort of peeling the onion. Why do we want to migrate these legacy applications? And then if we decide that we need to and we want to, and typically the answer to that is yes, then what are the paths? What are the different ways that I can actually do this? And you may be familiar with some of these, but some of these might be new, depending on what exactly you want the outcome to be. And then I frame this all up at the very end. I sometimes do this at the beginning, but I thought it might be appropriate at the very end, because this is what I like to stress with this is a journey, right? This is when you're thinking about taking a legacy application that's been keeping the lights on for, let's say, 30, sometimes 40 years. You have to have a roadmap, and you have to have an approach that is very much incremental and driven by what we like to call a factory approach. That's my intent with this presentation. I do have a lot, so I'm going to try to move kind of fast, but hopefully it won't be too fast. So, just to sort of get this out as far as semantics, technical debt, what do we mean by this? This is, I think we all pretty much have a good idea, but I just wanted to define this. This is the implied cost of what happens when we do not fix the problems, right? If we're still running vSAM in an organization, or we're running some legacy 4GLs in an organization, what is that? What is, what I like to tell people a lot of times, it's like these legacy applications aren't going to migrate themselves, right? So we have to have due diligence to come in there, and the wherewithal to look at and go, all right, what are my solutions and how can I actually do this, and what do I get out of this? Because there's different paths to do this, and what is this going to actually buy me? And that's what I hope to highlight in this. So the concerns, like Ron was talking about, is, a lot of times, especially in this day and age, when I was first starting to do this about 6 years ago, a lot of folks were just wanting to migrate their mainframes because, there's a cost savings. And I'm going to show that in just a little bit. There's a substantial cost savings with what you would typically pay to, some folks of like IBM or Unisys. But now what we have is we have a lot of these applications that reside on a mainframe that are really the hard ones, right? These are the ones that, the reason we haven't migrated them is because they're typically the most complex, and there's more risk because they're fundamental to the core function of the agency. Some other concerns that are out there that we need to look at is many of the developers who wrote the applications no longer work at the agency. If you go into a lot of state agencies, I used to cover state and local government, and we would go into the refreshment room, and there'd be a bulletin board with a bunch of retirement parties for people that were developers on these mainframes for 20 to 30 years, and they don't work there anymore. So that leads into the problem of, there's not a lot of people that know COBOL. That's kind of what I would say is a shrinking base of developers, right? So most people want to be in a modern language like C# or Java, in a managed language that's more easy to deploy within native cloud services like containers and things like Azure Functions and things like that. And typically, the other part of this, what I wanted to get into, because I'm actually writing a book on this, is most of these applications were monolithic, i.e., they all ran on a particular machine, and they all had easy access to each other. So they could share memory, they could share databases. And when we move into a microservices world, we're really getting away from that, right? We're getting into a world where each service has its own database and is very distinct from other services that are out there. And the thing to keep in mind also with these workloads is that there's typically a very large x86 support base around, I call it the x86 support estate that supports these mainframes. So this is for, when people have to call into the mainframe. We've built a service facade for this over the years. IBM's provided tooling for that. And those applications, whatever they might be, are really sort of trapped and hinged to this mainframe because of the next bullet, which is latency, right? Because when we put something, a message, and put it over the network, we're going to have some latency that we're going to incur. Is that acceptable? A lot of times it's not, right? So that's another reason why migrating these into a cloud like Azure is a good option. And another thing that I stress with this is that I'm going to cover a couple of different approaches for this, actually four with some variants. And I by no means do I want to ever suggest that one size fits all for this. And typically there's a lot of each of these solutions that we'll look at. But let's just go ahead and get started with the tried and true, the ones that you may or may not know about. But before I do that, I did want to talk about cost, because the cost savings, this is something to keep in the back of your mind when you're thinking about this. There is going to be, no matter what, whoever you do this with, and I'd love for you to do this in Azure, but you're going to have some upfront costs for the modernization. And this graph right here, you can see it's sort of depicting that. But the flip side of that is, once your project is finished and you are in a cloud platform like Microsoft Azure, then you're going to have a savings range anywhere from 60 to 90% of what your month-over-month cost was for that mainframe before. And that's where you can actually have the savings to, one, get your return on investment and break even, and two, actually look at additional modernization that you might want to do for those workloads. And we'll talk about that once we get into the different facets of what they are. The other thing, like I mentioned, the developer base is shrinking. And a lot of times what I'm finding more and more, especially in this day and age, is developers want a more modern language, and they want a more modern environment, a development environment like Azure DevOps, like GitHub. There's a huge push to actually push the dev management to one of those types of tools, because they're just a lot better and a lot more modern, and that's what people are used to. The other thing that, piggybacking off the previous session, is insights and analytics and AI. I just got off a call today where what's driving this mainframe modernization is they want to be able to use something like Copilot to actually do fraud detection for health and human services applications. So I'm seeing that rise up more and more. And then the other thing to keep in mind, when I've been doing this for a while, I put agility here, because what that typically means is, when we would talk to a mainframe customer, and it's not necessarily mainframe, it could be legacy Unix, and we'll talk about RPO, recovery point and recovery time objectives. A lot of times they're in days, right? I mean, like our mainframe can be down for days, and in this day and age, if you're down for days, that's really, really bad. And what we can offer in a cloud platform with resilient technologies like within Azure is we can offer a RPO and RTO that's specifically like in minutes, right? Typically that's what we want to shoot for. So let's go ahead and get into the first one here, which is what I'd like to do is, you might have plugged into this. If you're familiar with this, you might have seen this with Gartner. They called it the R's. The R's kept growing. What we decided to do at Microsoft was, we said, at the end of the day, there's really four patterns that are key patterns that we need to, conform to and look at. And the first is migrate, then we have transform, then we have extend, and then we have re-envision. So let me get into what each of those are and different examples of what they are, and some stories behind that. So when we talk about a migrate and a rehost, really what we're talking about is taking that monolithic application or applications that are running on the mainframe, and we're talking about recompiling them on essentially application emulators that run in Azure, right? In a VM typically, or these could be in containers. And what we have is, we have an analog for everything that is on the mainframe. So we need a scheduler, we need, we want batch process, and we have all these things that make up what a mainframe is, and we mimic all that. The way I like to explain a rehost once it's done is everyone goes home on Friday, they come back on Monday, and everything looks the same. And what's the good and the bad about that? So the positives and the negatives. Well, the positive is that it's probably the least risk because we're not introducing another type of language. Typically is probably the fastest for a lot of these because this is, what we're talking about here is very mature. And, the look and feel is the same. So your users that are used to this, it's not going to rock their world, right? What are the negatives? Well, I mean, it would be hard pressed to say that this is really modernization. It's definitely a step towards that because we have the transactional systems in the same cloud, so we can do a lot of things that we've essentially slayed the latency demon, right? So we can do a lot of things that we probably couldn't do before, and we can plug into, like I was talking about, the modern DevOps and things like that. But it's still pretty much the same tooling. And I like to frame this a lot of times as that this is phase one or step one, right? The next and the things that make this up is what we want to do when a customer is interested in this is what it would typically look like within Azure, as we will find an analog and what that would run like, and then we like to break this out into a rough order of magnitude by the SKUs of what this would typically cost. And we like to have a production system with a backup and DR system and performance engineering and all the different things that infrastructure as code allows. And we use that to frame the discussion. And what we find out is this number down here is typically 10x less than what their month-over-month cost is for their particular mainframe. And keep in mind, this is just infrastructure cost. A good example of this is the United States Air Force, who did this probably about, I think it was 2 or 3 years ago. They had a Unisys system that was migrated to, it was a Dorado system, and that was migrated to Azure. This was the system that was used for fleet management or fleet maintenance and management. And they essentially wanted to bring that into the cloud so they could do a lot of the things that you've seen as far as 3D, being able to incorporate the modern applications that could leverage that. And that was a big success. And they have, you can see some of the savings there, $23 million and 82% savings in the first year of actually implementing this. So on the flip side of that, down at the county level, we have a county that was in, I believe this was in Alabama. And this was very much a rehost where we took their code base and we cut their operating costs by 88.9%. And we did this with a partner. The partner was a Stadia, I do believe, on this one. And CEO was very happy. So I think this actually took maybe a little less than a year to actually do that. But here you can see there's 2 examples, one a big one and one a small one. So it's really it's not, like I said, going back to, it's not a one size fits all. And it really depends on what you want to do with. In this particular case, there was really just one application left on the mainframe. So this is kind of what we were talking about, right? This is one application left on the mainframe. If I can get this off, I can get rid of the mainframe and actually move forward. And that's what this customer actually did. So let's move on to Refactor. Refactor, very similar to Rehost and Migrate. But the difference is we're ending up in a modern language. And what do I mean by a modern language? I mean Java and/or .NET, and that typically means C# for .NET. And what does that buy me? Well, that buys me a lot of different deployment options, because now where I might have been married to a VM, not typically though, because we can actually still do rehost with a company like Raincode and put that in any kind of construct, because they compile down to .NET as well. But when we could leverage Java and/or .NET, we can target containers, right? And when we have containers, then we can actually start looking at cloud native services. And that's usually very interesting for a customer when we start looking at this, because that's typically a lot further along the modernization path when we do that. What are so that's the positives. The negatives, what are the negatives? A lot of times this is done with special SDKs that need to come along with that for the third-party compiler tooling. And not always, but it's something that needs to be considered. And it's not a true microservices architecture, and I'm going to talk about that in the next couple of slides. But it's getting closer. So let's a good example of this. Won't spend too much time on this, but the Geico actually did a refactor where they targeted a COTS application, and other applications were actually they wanted to get away from COBOL, and so they targeted, I believe it was Java for this particular case study. And all these slides are available if you want to dig into this, and I have some contact information if you want to have a further discussion. So now let's shift in and talk about Reenvision. Reenvision means I want to re-architect this application. I'm finding this very popular in retail, and I'm finding it very popular in transportation. What are the positives? Well, we end up with a true microservices architecture, right? Modern, agile, everything that you've read about. So a lot of times people would go, well, yeah, if I could wave a magic wand, this is what I would like to do. What are the negatives? Well, it takes a long time, and it takes a lot of very smart people that know, one, how to look at the monolithic code, and two, how to take that and decompose it, as they say, into microservices. And so let's just take a little step into what is that exactly does that mean. And I thought to best describe this, I'd do a brief little history lesson in application development. So, applications typically, back in the 60s, 70s, and 80s on mainframes, they were monoliths, right? They were applications that ran on one machine, or a KEC, as they used to be called, where you hook mainframes up, but they had access to typically one database. And exchanging information between applications was a breeze, and it was, sometimes led to shoddy programming techniques, especially when it gets into distributed, because they didn't have to deal with things like, networking and things like that. But one thing that came out of monolithic architectures was modular programming. And modular programming led to service-oriented architectures, which is really big in the late 90s into the 2000s. And this is where we really adopted this concept of a service. And the service, didn't necessarily have to have its own data, but it was responsible for its own data. And we could talk to it, and it could be decomposed. And going from modular, a modular monolith into something like an SOA, service-oriented architecture, was very popular because it gave us more agility. And then where we are now is in a microservices architecture where technically, by the definition, every service has its own completely separate database and is responsible for that. So you can see that bridging that gap actually in architectures, when you're looking at this, it's not the easiest thing to do. It can be done, and it's usually worthwhile to do that. And the good news is that just because it's in COBOL does not mean that the COBOL cannot play in any of these services over here. It can, and it can be COBOL, like I said, or typically .NET or Java. I wrote a blog/white paper probably about 3 or 4 years ago, and it was really targeted towards mainframes. And it was essentially, if you had a CICS mainframe and I wanted to decompose my COBOL transactions into containers running on an AKS or a Kubernetes deployment, it would look something like this. And I put this here really just for illustration. If you want to, ping me, and if you go out there, you can find it on Google. But it's I had a lot of interest in this, and so folks are very interested. And here, your database can be whatever. It doesn't have to be SQL Server, although we're finding a lot of interest in that. But this just kind of shows you a manifestation of what I was talking about. A good example of this was actually, I believe this company was over in Europe. But what they did, and I have others that I can mention, but that I can't mention the customer, but this is just a good example. They actually refactored and reimagined their core applications, and it worked out very well for them. So now the last one that I wanted to talk about is Extend. And usually what I see Extend is, as a customer base, is for larger customers that have big investment in their mainframe. And what they want to do is they want to modernize their DevOps. They want to do the fraud detection that I was talking about. And IBM has created, and we actually partnered with them on this. They have something called Zoe that we have been working with them on. We actually have a very good partnership with IBM as far as integrating cloud and expanding and extending the mainframe workloads and footprints into, things that are cloud native within Azure. And a good example of that would be Azure DevOps. So that's what we mean when we're talking about extension. And then this gets back to my approach of, how do we do this? So I just presented a couple of different facets. And usually if you're a larger mainframe, you're probably going to do one of each of those, right? I would say just the one approach for larger type workloads is really, it's not, like I said, one size does not fit all. But what we like to sort of put out there is that when you create a factory approach, the premise underneath this is that, all right, I'm going to do a workload, and the first time I do it, it's probably going to be hard. I'm going to have a lot of learning that's going to take place, but the next workload, I'm going to have all that learning to take to piggyback on top of, and so we're going to get better at this. We're going to iterate, and that's where the agile, when we start moving toward this cloud optimized step, where we get to cloud native. And once we create that flywheel approach where we go through and we iterate, then the actual time to actually do this and the risk and the errors that we incur become less and less, because quite frankly, we just get better at it, just as with anything. So that's the approach that we like to use. I'm finishing up. I wanted to just put some things out to make you aware of these are things that you would need to be aware of. Dapper, distributed application runtime. I liken this to the scaffolding. If you're going to build something onto a house or something like that, you're typically going to have to build substructures that are going to be temporary, that you're going to take down, right? And Dapper is a good example of that. It can be used for anytime you want to have apps that are like multi-cloud. Some are in GCP, some are in AWS, some are in Azure, some are on-prem. Dapper is it's something that Microsoft created and then submitted to open source. But it's really good because when you're migrating from a mainframe, a good example, or a legacy Unix system to something like Azure, you're going to have your feet in two worlds at the same time, and you're going to need to have applications that can communicate back and forth, and you don't really want to have to rewrite the application. You want to make sure that those applications have as minimal touch as possible. And so Dapper is a good approach to actually do that. And almost done here. The last thing I wanted to talk about was Azure Landing Zone Accelerators for mainframe. And what we've done here is when I was in engineering, I used to be in Azure engineering, and we put these reference architectures together over here, and you can kind of see that. One of the things that we noticed, especially for SAP workloads, is they took those reference architectures and they spun them into something called an accelerator. And what an accelerator is really just something where I can click a button and I get this. It's deployed within minutes within Azure. And it has all the artifacts, the plumbing, the networking, the VMs and or Kubernetes deployments that are ready. And the nice thing about it is that it plugs into this thing that we call the WellArchitected Framework, which you're seeing an example of that here. This is security and best practices that are tried and true. And what we work with the vendors that actually create these accelerators, and they just plug in. I call this the Lego slide, because they plug in and they get the immediate goodness and benefit of all of this well-architected framework. So that was a rush, and I apologize for the speed. It was a lot of content to cover. If you are interested at all, please reach out to me. I cover state and local governments for Microsoft and some other industries as well, but would love to have a conversation with you about how we could talk about modernizing your legacy workloads.